Hi, I'm Yuri. In this short video, I'd like to describe you mlcourse.ai, an open machine learning course. So if we just type mlcourse.ai in the browser, this would lead you to this main page, which is currently a Jupyter book. So there's a major update to the site that I would like to share. And if you hear it for the first time, so this is an open machine learning course that I was leading for 3 years from 2017 to 2020. And at the moment, it's in self-paced mode. And I would like you to give instructions on this course. So even though it's in self-paced mode, it can be really helpful, and you can learn a lot if you invest your time in the course. So I'm Yuri. I've got a PhD degree. I'm also Kaggle Competition master, and I'm a senior machine learning scientist working in industry. And yeah, it's not just about boasting and showing off, but I really wanted to create a course with a perfect balance between theory and practice. So that's why this course is a bit math heavy, so it has some prerequisites, but at the same time it's very, very practical with a lot of assignments and Kaggle competitions. And I would like to describe you the course in a bit more detail. So on the main page you see instructions how to navigate the course. So we describe this Jupyter book, which is a perfect format for an executable book. So whenever you have code, math, figures, anything, I really recommend rendering these with Jupyter book, so which is pretty neat. And apart from the main track, we also have bonus assignments, which I'll describe. A big update on for Russian speakers. So I'm currently describing you a self-paced English version of the course, but Russian course is back in its active form with 2 sessions per year, with chats, active competitions, and so on. So the first session starts on February 1st, 2022. So if you watch this today, it means tomorrow. And for Russian speakers, it would be the best place to learn the machine learning for free. Well, this page is apparently in Russian, but the course will be now led by Peter Ermakov. So I worked with him a lot, so he's got, I guess, even more experience than me, in teaching data science, both in academia and in corporations. And so for the Russian versions of the course, I think I found a nice successor. And the English version of the course is still in self-paced mode, so I will, in the next 10 minutes, I'd like to go through the self-paced version and briefly describe what we have here. So first of all, we listed prerequisites more or less thoroughly. So you need to know Python, you need to be comfortable with writing loops, functions, and classes, and so we recommend some resources here as well. As for math, so some assignments, as I mentioned, will be math heavy. So we also give some links to resources on math. And well, for instance, to understand how simple algorithms scale to gigabytes of data, there is some math involved. So for example, in the assignment on stochastic gradient descent, we have some math formula, and yeah, it's of course, it's holy war how much math you need for doing data science, but to really understand the algorithms, it's highly recommended. And so we give instructions here. And of course, instructions on software, DevOps, things like Docker. And then we start with topic 1. So you see it's a Jupyter book, so you can basically just use your left and right arrow to go through the content. So for each block, and we have 10 blocks, we describe all the steps in the blog, so articles to read, video lectures to watch, and then demo and bonus assignments. So let's just spend a bit more time with topic 1, and then we'll skip through other topics quicker. So we give an article, which is hosted, well, basically on the same platform as a Jupyter book. And yeah, it's an introduction to Pandas. So we demonstrate some main functions, and you see it's rendered. So the big advantage of Jupyter book is that it's executable. So it's an output of the actual code, and it's easy. So this type of format serves as tests in its own. So you can always execute the book and be sure that all the code is ready, it's correct, and you can reuse it. So you can just skip through, read this article, but of course it makes sense to play around with code, and so you can download it here as a Jupyter notebook, or you can even open it with Binder and work online with this book, with this particular lecture. And then, so this is the preferred option, but if you'd like to watch a video lecture, yeah, so there's also an option. So, well, it's fairly long, I would admit, so it's about an hour, or sometimes lectures are about 2 hours. So, but if you prefer this option to watch me real life typing, live coding, that's optional. So the main content is still in text, but if you'd like to spend more time, I would recommend video lectures as well. And then we have demo assignments. So in this case, it's a dataset that we'd like to analyze with Pandas, and then we ask some questions to the dataset, right? So you first read it with Pandas, and then we would ask you questions like how many men and women are represented in the dataset, or going a bit more into detail, writing some Pandas code for some queries to the dataset. So performing EDA, exploratory data analysis. Well, it's a fairly easy task, so easy to follow if you just cover the lecture, and then we immediately share the solution, so we can always align with the solution. But then we also have bonus assignments, and in this particular case, it's analyzing a bit larger dataset, and well, maybe it's a bit more interesting to analyze. So we reserved some cool assignments as bonuses, and you can get those while becoming a patron. And hopping over some more topics. So in the second part, we discuss visual data analysis, and we go into the details. So how would you approach data analysis? So it's quite different from how others treat visual data analysis. So we really cover these steps. So what you would typically do when you get a dataset. So which graphs would you plot? How would you explore the dataset? And so it's not just about just creating cool pictures. So we cover Seaborn, Matplotlib, and Plotly, and discussing all these steps. How would you analyze the dataset, especially in the video lecture? And yeah, of course, some demo assignments. And for instance, for bonus assignments, we are taking now a much larger dataset on flight delays, and it's about 1 gigabyte in size. And this time in this bonus assignment, we go more into the details of efficiency. How would you read such a dataset into Pandas, and perform efficient operations, and, well, of course, visualizations. Well, the actual machine learning starts with topic 3 on decision trees and k-nearest neighbor, and we go into the details of the whole idea of supervised learning. How would you choose model parameters? We describe the very important concept of cross-validation, so how you would typically validate the model, tune hyperparameters, compare it to models, and so on. In topic 4 is very large, and we cover linear models here. So it's a very, very nice baseline, both for classification and regression tasks. And we cover the math behind ordinal linear regression. Then we pay attention to linear classification and logistic regression, and we really dive into math. So of course you can skip this part, like how maximal likelihood estimation leads to logistic regression. Of course it's optional. But it really helps to understand this big picture. And then further, if you'd like to delve into deep learning, that would be a natural step. So understanding maximal likelihood estimation and how this leads to logistic laws for logistic regression, that's actually essential to understand large models and backpropagation algorithm, and many topics in deep learning as well. The demo task number 4 is about regression. So just analyzing a data set. But bonus assignment number 4 is much more interesting now. So here we come to Kaggle Competitions. So it's about beating benchmark in one of Kaggle Competitions. Actually set up this competition with real data. So I was reading an article which introduced a couple of models, and well, the article was not really good in my view, but the dataset itself was pretty useful. So it was about log sessions and some server logs, and the competition is about actually identifying we can call the guy an intruder, so detecting a person by tracking web sessions. Now I would say maybe I wouldn't arrange such competition right now. There might be some ethical issues about tracking a user on the internet following web sessions. But yeah, maybe some 4 years or 5 years ago I didn't think about it. And well, anyway, the competition is very, very interesting. So it actually makes you perform EDA. So comparing a user, we call a user an abstract user Alice and try to distinguish Alice from everyone else following web sessions. And the competition really encourages you to build plots like this one, so trying to analyze Alice's behavior. And then what's the best part? You would create features, add them to the model, and then you would climb up the leaderboard. So you are adding a feature, maybe you're somewhere on 260th place, and then you add a couple of features and you climb up the leaderboard, and you are now then, let's say, on the 40th place. So it's really exciting. And feature engineering is also maybe the most interesting part in all of machine learning, analyzing data, adding those to the models. And the competition is actually very, very successful in this sense. And you can climb really high with just linear models, which are considered very simple, and with careful feature engineering. So then topic 5 covers bagging and random forest. So random forest is long considered a workhorse in machine learning, so it works extremely well. And we go into the details, so including also some math details, why it works so well. But we also here cover something really new. So I'm also describing a business case where I applied random forest, so that was predicting customer payment, and yeah, that's something you wouldn't find in academic courses. So taking a real task from a job, taking a real data set and describing it in detail. So I would really appreciate if you explore the video lectures, not only on the theory or practice of random forest, but also on this business case. And then in topic 6 we discuss feature engineering in more detail. So the article is about all different types of features, so all different types of data, including images and text. So just an introduction. But bonus assignment 6, it opens yet another Kaggle competition, and it's about predicting popularity of a Medium post based on its text. So it's here we touch a bit of NLP, so natural language processing, and the competition is very, very useful. Here you would work with something which resembles real data much more, so that you would get a lot of data in JSON format. You would extract features from them, and again, perform feature engineering and climb the leaderboard. So this is another Kaggle competition which might be really useful, especially if you'd like to work more with textual data. Then we cover unsupervised learning, and well, it's a huge topic, but here we mainly pick principal component analysis and clustering. In topic 8, we discuss Vopl-Webbit. So it's a tool, just a command line tool that helps you train models with dozens of gigabytes of data. So you don't even need a Hadoop cluster for some jobs that require a lot of data. So you can just use an efficient command line tool. But we also go into the detail of stochastic gradient descent and the math behind it, and why it would really make these models so efficient. So we discuss gradient descent, and the style of the lectures, we try to keep it more or less informal. So here describing gradient descent, I show the picture of myself in Sheregesh snowboarding, and then just drawing these resemblance of stochastic gradient descent and selecting the greatest slope on the mounting. And later we come to use this tool, Vopl-Webbit, and the assignment is about using these data, let me check if it's demo assignment. Yeah, so we show examples how you can train these models with gigabytes of data, with say 10 gigabytes of Stack Overflow questions. And here the demo assignment is also very valuable. So where we cover mathematical details behind linear regression and stochastic gradient descent. So this demo task asks you to implement stochastic gradient descent regressor, and well, you really need to understand the details to implement it correctly. And yeah, it goes with the solution. And in a bonus assignment, we just go deeper and also implement these for classification. So we take logistic regression, so a classifier, and create a stochastic version of it, which is as well very, very efficient for many, many tasks, and that can scale to really large data sets. So topic 5 is about time series analysis, and it's a very nice contribution from a former colleague of mine, Dmitry. So he wrote a really great article covering many, many different approaches to time series, including the classic ones, including econometric approaches like ARIMA, but then also using what we would say a machine learning approach, where you just create features, pick up boosting, let's say, or random forest, and then treat time series prediction task just as a supervised learning task, and apply algorithms like random forest with carefully engineered features. And then finally, in topic 10, we cover boosting. So again, this course is not about neural networks. So it's what we would dub as classic machine learning. So we stop at gradient boosting, which is a very, very powerful algorithm, and it's widely used in practice as well. We go into the details in a bit of mathematical details. And this article is a contribution by Alexei Natyakin, the leader of Open Data Science community, ODS.ai. And it's a very well done work. So covering the history of gradient boosting, discussing different mathematical details, and also in the video lecture we cover practical applications. So for instance, the differences between major boosting implementations, XGBoost, LightGBM, and CatBoost. The first part is again about fundamental ideas, and the second one is more about the practice. And the bonus assignment here, maybe it's alone worth actually buying this package. So it's implementing gradient boosting from scratch. So we delve into the mathematical details, how gradient boosting actually optimizes loss functions, but then we take a toy datasets and drill down deep into the implementation and to understand how gradient boosting actually one iteration after another, how it actually fits the function, and how it actually makes the model fit to the data, and why it's so efficient. And it's really a pretty long assignment and very, very hands-on with a toy dataset, and it also builds many visualizations, so you really understand how gradient boosting works. And by the way, it's a pretty popular question for machine learning interviews, describing how gradient boosting works. Where do you find gradients there? Maybe for me it's one of the most popular questions about gradient boosting. So there is a word gradient there. So where do you find gradients? And then it's all explained here in the lectures and in the task. So some more sections here. So we've got tutorials. So in the former live sessions of the course, one of the assignment was to write a tutorial. So many students wrote really nice tutorials, and we list them here. Some of them are really good. So just to pick one example, about multi-armed bandits. Let me see if I can spot it. This one immediately by Alexei Grigoryev. So sorry, cannot find it immediately. One of the guys was working a lot with multi-armed bandits and online ads, and he really shared his experience working with these bandits and delving into the math and sharing hands-on experience. How would you set up experiments to understand whether one ad is better than another? Now I understand, sorry, that this particular one is in Russian, so it would be nice to translate it, but others are in English, and some of them are really good. Then we also list the heroes. So in each of the 6 sessions from the beginning of 2017 to the end of 2019. We had large sessions with thousands of participants, and we list top 100 performers from each of the sessions. So, well, instead of a certificate, you can basically make a link to this page if you passed the course in the past. So then we also list some more resources. So there's this difference now between the English version of the course and the Russian speaking one. Yeah, we provide some links here to this open ML course in Russian as well, which starts, yeah, if you watch the video today, for you it would be tomorrow, February the 1st. But Peter Ermakov also plans to run multiple sessions per year for at least 3 years. So yeah, we'll see. And then here you find some links to YouTube playlist with the video lectures for this course. Then all the material is also available as a Kaggle dataset. So basically you don't need anything apart from a browser, and then you can start immediately working with course materials. Yeah, you know, all the data is already here. So data that's used in the course, all these files, and then yeah, notebooks by me or by other participants. If you just sort them by, I would say, most votes, yeah, then there's the course material. And there's also, yeah, for Russian speakers, there's a VK mlcourse.ai group, and yeah, and of course GitHub repository, which you can use to download course materials and play around with them. And yeah, for instance, all the content of the Jupyter book is stored in a separate folder, and there are even more notebooks in English, French, Russian, and Chinese. Yeah, we've got contributions from others. Yeah, and finally, contributors to this course. So enjoy. You see, there's a lot of content already shared for free. And well, of course, if you start working with the material and you see that demo assignments are cool, and you can yeah, you can compare your solution to the solution shared by us, and you find it useful, and so on. So yeah, you can consider also becoming a patron and getting access to even more assignments. That's it. Thank you, guys. Cheers.